Hello and welcome back. In our last video, we diagrammed one of Stephen's processes that was partially coded and had areas for more code to help him improve the process, and we drew that out. In this video, we're going to get a little bit more advice from Stephen on how to move forward before we take a look at a process that I don't know about you, but I do every day, and think about some code that we might use to make that a little bit easier. All right, let's take a look.
I would recommend to students and really to anyone to do something similar, which is when you have some sort of process in your life, some sort of pattern, write it down. And then ask yourself, does it have to be that way? If it doesn't, write down an alternative. And then decide which one is better according to some metric.
All right, so that's exactly what we're going to do, what Stephen recommended, which is find a process, write it down, write down an alternative for that process. Specifically, we're going to add some code to speed up that process, and then we're going to take a look at both of those by a couple metrics to see which one might be better and give it a try. So I chose something that I don't know about you, but I do every day, which is choosing what to have for lunch. So this is, I predefined out my typical process for choosing what I have for lunch. So I first decide it's time to have lunch. Then I look through all the places where I have food. So I'm looking in the fridge, what do we have? I look in the freezer, is anything good in here? Look in the cabinet, what about all this stuff? Look on the counter, what sort of fruits and veggies do we have? And then I think about, well, if I have this, I could have this on the side. Do I want to make sure it's balanced enough? Finally, and then I also think about, what do I feel like eating? Finally, when I decide, then I'm on step 9, assemble, and finally I eat it. It's a pretty long process. I took this and I thought about what I could use code for to make this a little bit faster. Big chunk of this is looking around to see what I have. What if I already had that information somewhere, say stored in some code? I also spent a lot of time thinking about what I want to have. What if I had a program to make that decision for me? Here's my sample process. So I decide it's time for lunch, and then I run a program called Lunch Chooser that picks a meal for me based off what I already have. Then I assemble that meal and eat. So looking at these two processes, very quickly one metric we can look at is how many steps does it involve? This one's 4 steps versus 10 steps. Imagine this is going to save some time, maybe. Might save some stress not having to just make all the decisions. So this new process, looking at it for deciding for lunch, there's enough metrics predicting that this might be a better way of doing things that we're going to move forward with some code. Let's give it a try. So I have WeScheme up here, which is an online platform for writing code in the Scheme language, which is a Lisp language. Lisp stands for List Processor, and what we're going to start out is by defining some lists of the food that I have around in my house. So how we're going to do that is we're going to start with the define, and then we're going to break down, say, making a balanced meal is pretty important. So let's say we want to do protein. So we'll define different types of proteins. We'll also define, let's say, ways to eat that, like maybe it's in a sandwich, maybe it's on a salad. So let's call that methods. These are blank right now. I'm going to fill them in a moment. And then the last thing I'm going to define are veggies. So my proteins are going to be a list, as I said, that list processing language. Lists are going to come up a lot of a couple different proteins. I'm going to make these strings, which are a collection of characters, like words. So I have turkey as different protein. Let's do chickpeas. Let's do maybe peanut butter is nice protein. And let's do one more. Let's say meatballs. All right. So my list of proteins. And now I have a list of methods. Let's see, as I said, maybe I do this in a sandwich. Maybe I have it on a salad. Maybe I have it on crackers. Maybe I have it as a wrap. Oops, that's warp. Let's have it as a wrap. Great, so those are a couple methods. The last thing I'm going to define are some veggies. Let's see some veggies I have around my house. I have carrots. I have tomatoes. Typing under pressure, man. Celery, and one more, let's say broccoli. So if I run my code right now, nothing's going to happen, but I did define those. Nothing's going to print out on the side here, but I did define them so we can see if I type out proteins, there's my list. If I type out methods, veggies, those are my list of my options. Now I want to not only have those options, but I want to have a random pick those randomly. So I'm going to define a function. These are constants holding some information. I'm going to define a function to do something with those. Let me spread this out a little bit so we can see. So I'm going to define a function. The difference between a function and a constant is I'm going to wrap this in parentheses because it's going to take in some information. I'm going to make a function called random food, and it's going to take in one of these lists. So it's going to take in a food list. That's the name of my argument. So I could pass in veggies, methods, or proteins. So we don't have just a pick random function. What we're actually going to write is something that references the ID of something in the line and picks that out, randomly references one of those IDs. So we're going to use something called list ref, whereas if we pass in a number, it will find that item in the list, and it's going to reference that in the list called food list. So it's going to take whatever that is, put it right here. And what number it's going to reference is a random number between that is the length of the list. Because here all of them are 4, but what if I want to add a number? I want it to be 5 or 6, or I add one more, something like that. So I always wanted to pick the random based on the list that it's given. So now if I run this code, let's say I want random food from methods. And it gives me on crackers. Let's do a couple tests of these. I'm just going to copy this here. Let's do veggies. Let's do another methods. So we have the random food function. The last thing you have to do is assemble those proteins, methods, and veggies into some selection together. So let's define another function, which is going to be called, as I said, I called this before, lunch chooser. Now this it's still a function, but it's not going to take in any arguments. It's just going to be called that function. What that function will do is, and I'll show you why it's a function and not just a constant in a minute, but it's going to use a function called string append, because as I said before, these are strings. It's going to put these together, but I'm going to make a full sentence. Let's say, for lunch today, you should have, I'm going to put a space there, because the next thing I'm going to put here is it's going to be a random food proteins. For example, it could be turkey. Then I'm going to go ahead and say random foods methods. And let's add another string here, and let's do with a side of. And you'll see why those spaces are important. Random. Oh, I've got typos left, right, and center here. So random food veggies there. Make sure all my parentheses are closed. Let's make this a complete sentence by putting a period at the end. Let's go ahead and test this. So if I run lunch chooser, for lunch today, let's see what it says. For lunch today, you should have a turkey wrap with side celery. Ooh, look at that. Looks like I forgot to add a space. Let's test again. Peanut butter sandwich. So what happened was there should be a space in between here, because you can see There is no space between peanut butter and sandwich or turkey and wrap because there's no space between the random protein and the random method. So I just added that in here. Let me make that really clear by putting it right there. Let's run this again and see. For lunch today, you should have a chickpeas wrap. Maybe it should be chickpea and meatball with a side of broccoli. Lunch today, you should have chickpeas on crackers. Nice. All right, so let me demonstrate why, for the last thing, why we actually made this into a function. If I take that away, now it's a constant because so I took those parentheses away. It is now a constant. If I run this and run lunch chooser, for lunch today, you should have a peanut butter wrap with a side of celery. Let's run that again. Copy, paste. For lunch today, you should have a side. So it's giving me the same answer every time. Because one of the main differences between a constant and a function is when I first run my program, all the constants are run once. It defines proteins as this, it defines methods as this, it defines veggies as this, it defines lunch chooser, and it runs each of these random functions once. That's it. But when I make it into a function, it means every time I call it, it's going to run lunch chooser again. Rather than just reference it, it's actually going to run that program again, which means running random food every time. So I'm going to get a different response every time, which means say I don't like the peanut butter wrap with a side of celery because that sounds very weird. I can run my program again and get a different answer. All right, so we did a lot of cool coding today. We defined constants in a function in order to several constants and a couple functions in order to speed up our process of choosing lunch. Thank you so much for joining me as we code some of our life. May seem like it starts simple, but this is where you start. Start thinking about this in everything that you do. How can I make this better and faster using code? Code your life. All right, thank you so much for watching. If you're on Udemy, go ahead and continue on to those assignments below. And for everyone, I will see you next time. Stay safe.